Welcome to this next example, which reads, Massey swings back and forth on a swing with ropes that are 4.00 meter long. The maximum height she reaches is 2.00 meter above the ground. At the lowest point of the swing, she is 0.500 meter above the ground. What is her maximum speed attained and in which position? So that's the question. These are answers that we must prove. We have an illustration here. This is the suspension for the swing, and this is the rope. Let's say that's point O. The rope is given to be having 4 meters. 4 meters, and we are also given, this is the reference level A. So if the particle, or if Massey is given a velocity at point A and starts to swing, there will be a point B where Massey has reached a maximum height and momentarily comes to rest. So at point B, because she momentarily comes to rest, it means that she does not have any kinetic energy. Basing on the conservation of mechanical energy, at point A, she has maximum velocity because that's where all the motion starts. Therefore, she has maximum kinetic energy at A. This whole maximum kinetic energy at A will be converted at the converted to potential energy at B, and that's the law of conservation of mechanical energy. So if we read through the question, the rope has a length of 4 meters. We are done with that. And the maximum height she reaches is 2.00 meter above the ground. So let's assume that Massey is this ball here. So this is Massey swinging. She at her maximum height, she is 2.00 meter above the ground. So this is the ground here. This whole distance is 2.00 meter. And then at the lowest point of the swing, she is 0.5 meter above the ground. So this is the lowest point at A. We are given that she is 0.5 meter above the ground. So now we know that if her motion starts at A and then momentarily ends at B, she has risen a height from point B to the reference level of A, and now that's going to be 2 meters minus 0.5 meters, which leaves us with 1.5 meters. So that will be the height which she rises when she swings from A to B. So now we want the maximum speed, but in which position? We know the position, that it's position A, because that's where the whole motion starts from, and at the lowest point she has maximum kinetic energy. If we move on using conservation of mechanical energy, we shall see that the kinetic energy at point A should equal to the potential energy at point B. If we assume that she's swinging in the air and there is no air resistance, or air resistance is too small to be ignored. Therefore here we shall have the kinetic energy, which is a half times the mass of Massey. V squared is equal to mass of Massey times acceleration due to gravity times the height through which she rises. Then you can see that the mass is here and the mass there, they are the same. Since we want the maximum speed, if you want, call this V max. So V max is now going to be the square root of 2gh. So V maximum is going to be the square root of twice the acceleration due to gravity multiplied by the height, which we have as 1.5. So V maximum here is going to give us, if we put the figures in the calculator, it's going to be 5.44 meters per second.